Hello, everyone. Why don't we get started? I'm Ben Hohen. I'm a research scientist at Berkeley Lab, and I have the pleasure of hosting Chris Garrity of the United States Geological Survey today. He's going to tell us about the new Application Programming Interface, or API, functionality that has recently been added to the U.S.Wind Turbine Database. Before I make some quick introductions and turn it over to Chris, I'm going to conduct a little bit of housekeeping, letting everybody know, as you probably have already heard, as you are calling in or logging in, all the participants are in mute only for the webinar. We are recording it, and in part because we're recording it, we've kept everybody muted, but we want to hear from you, so please submit your questions at any time via the chat window. I will be monitoring that chat window throughout the presentation and also at the end of the presentation to give Chris a chance to answer some of the questions. So let's go to the next slide, if you will, Chris.
Okay.
Yeah, there you go. Great. All right, so this is the United States Wind Turbine Database team. I just thought I would re-emphasize that this is a group effort. The Turbine Database has been built through a collaboration between Lawrence Berkeley National Laboratory, the United States Geological Survey, and the American Wind Energy Association, and the various representatives of those organizations are shown here. I'll just point out that Joe Rand, who's on the call with us today, who's a researcher at Berkeley Lab, is the one that heads up the database management side of the database. Louisa Kramer from the United States Geological Survey leads the visual verification effort of the database, which is crucial to understand the exact locations of each of the turbines. And Chris Garrity, who will be featuring today, is really the brains behind the quality of the database as you see it. He's the one that developed the website and the viewer, and also developed the API functionality that will be the subject of today's webinar. I'll also note that our work from the Lawrence Berkeley National Laboratory is supported by the Wind Energy Technologies Office of the United States Department of Energy, so we thank them for their support of this work. So I guess that's it for housekeeping. Please do submit your questions via the chat window, and I'll turn it over to Chris to lead us through the presentation today.
All right. Thank you, Ben. Can you hear me okay?
I sure can. I'm going to be on mute myself, but I can hear you perfectly. Okay.
Looks like there's a little bit of a lag in the slide transition here, so should be interested with some of the animations on how it goes. Anyway, as Ben mentioned, my name is Chris Garrity. I'm with the U.S. Geological Survey. I work on a variety of projects throughout the agency. Many of them have geospatial application development workflows and tasks. And certainly in the last 3 to 4 years, I've been leveraging data services via APIs more than I've been having to take the raw data downloads, convert them to services, and host those services to feed my applications. Right? There's been a significant change in kind of the way that organizations are onboarding APIs as a data delivery mechanism. And so today we're going to quickly talk about what an API is. We're going to talk about how our users can access the data behind our API. We're going to talk about how the content providers or the data authors on the Turbine Database side can use our API for efficiencies in internal workflows. And we're going to highlight some of the key features of the Turbine Database API that can certainly be applied to other web APIs. So as I mentioned, I'm using APIs in my development task. But for those who aren't developers, there's probably no question that you're also onboarding APIs just using applications on your smartphone, for example. So the API stands for Application Programming Interface. And what APIs do, they allow disparate software to talk to one another, right? They kind of connect our modern web environment. So, for example, if you hail Uber, you're using the Uber API, which in the background is connecting with the Google Maps API to get an idea of how far the Uber is away from you and how long it's going to take to get there. So behind the scenes, these disparate services are talking to one another through their APIs. It's very common for a simple example to think of an API as a waiter. So if you have people that come to a restaurant, they have a menu of predetermined items that you could certainly customize, but there's a protocol. There are certain menu items you can order. You essentially request those items to the waiter, who acts as the translator, who moves it to the kitchen. Kitchen prepares the request and sends it back to the waiter. So the API is essentially the translator. Now, how that works in terms of the Wind Turbine database is that we have our patrons are essentially our clients and our internal authors, the authors of the database. We interact with the API framework, which is again the translator. It sits in between the database and our clients. And then we have, in our case, we have a Postgres database on the back end. So essentially our API framework is passing the request as a SQL statement to the database, which returns the data, and in turn returns that data to our clients in the HTTP protocol. Okay, so essentially just in any environment, the API framework in the middle is doing the translating. Before we go into too much detail about the API itself, I do want to mention kind of the database at a glance for those who are unfamiliar with the Turbine database. It's a relatively small database, so it's only about 60,000 records. Those records have about 24 attributes. Attributes include things like the project developers, manufacturers, turbine specifications, those type of things. We have a plethora of data and services available for users. We have obviously raw download databases, data endpoints like CSV files. We have geospatial services, and most recently we have, as of 2 weeks ago, a public-facing API endpoint to consume the data. We do have a mobile web application for users who just kind of want to see what's around there and interact with the data without having to download the data. And that's honestly, that's most of our users. They're going to the web application and interacting with the data that way, right? So we have a plethora of services available for a wide range of users. Before we thought about extending the Turbine database as an API, we wanted to make sure that it was worth doing, because APIs, although they're very powerful, they do take a little bit of time to kind of to onboard, especially when you talk about things like documentation and security. So we wanted to make sure that database was a good candidate. And the first thing we wanted to make sure is that we had enough pool of people to actually leverage the API in a variety of environments, both custom application building or in simple desktop applications like Excel. So one of the nice things about the database is we've had some relatively high visibility. In the last year, we launched, in May 2018, we've had 1.5 million visits. Another good candidate that made this a good candidate, for API extensions is that we update the database quarterly. We've had about 70,000 record updates since the initial launch. But what that means is people that went out and grabbed version 1 of the database and never came back are way behind. One of the nice things about the API is that when you consume the data through an API, you're always in sync with the latest version of the database, right? And we'll talk about that and show that in a couple slides. Also, as many of you know, this is a database where we have multiple internal partners, and we're passing sometimes flat files, snapshots of the database to one another, and that sometimes can cause error and things like validation, whereas an API-driven database workflow has built-in database validation checking, and overall is more efficient when you have multiple database authors, and I'll show some examples of that as well. So what happens when you add this kind of API framework in between your database and your users? Well, in our case, we have a public web API. our database is boiled down to a single URL, single what we call root level endpoint. That URL is seen right there. And if you were to put that URL into a browser, for example, it's going to return to you all the data in the database, right? It's the root level resource, essentially. We can customize that resource to make it much more efficient for those who don't want the full database, and I'll show you that in a little bit. But the point is that any application, any software that can leverage an HTTP response can leverage the data in the API. And if you have software that's been updated in the last couple of years, chances are there's no question that you'll be able to leverage these API data streams. I'm going to show you a couple examples. The first one will be a very common platform, Microsoft Excel. Many of our users use this to look at the data. So in this case, I'll just click the From Web tab right there, enter that URL in the widget, and I'll make a connection in Excel to the database endpoint. Here in this intermediate window, I can set queries, I can change the stream, but in this case, I'll just accept the defaults and pull in all the database headers, all the columns. So at that point, I'll just load that up, and now I have a connection to the database. You'll see a familiar Excel window. So I'm connected to the database. Up there in the top right, there's a refresh icon, right? And what's nice about that is for our Excel users, if they want to make a connection or they want to be in sync with the database, all they had to do is hit that refresh button, and it's going to do a repull of the latest version of the database, right? It's very important in that our users stay in sync. We want to make it as easy as possible. As I said before, if they just downloaded the CSV file from version 1, they'd be way behind. So we make it very easy to connect and keep our users up to date in whatever platform they're accessing the API information in. So I'm going to move forward to if I was more in a development world. So let's say I want to make a very simple geospatial application showing the points from the API. Traditionally, I might take the raw data, build a geospatial service, host that geospatial service on my servers, and point my application to that service. But now, since I have an API in place, all I have to do, you can see the code there, it's like 4 lines of code. All I have to do is essentially paste that URL into my JavaScript, and it parses those 60,000 points on the fly dynamically. I don't need to have a server hosting services, and most importantly, I'm in sync with the database. So every time I refresh my application, it's crawling and rebuilding. So I'm in sync with the database. I don't have to rebuild services. I don't have to go fetch updates to the database. As you can see, I'm parsing 60,000 geospatial points in less than a couple seconds. There is a bit of a lag in the animation here, but trust me, it's very, very fast. And from a developer standpoint, I mean, it's simple, right? A couple lines of code, and I'm there. So what does the data look like? When you request data from the API, it comes in a format called JSON. JSON is JavaScript Object Notation Language, and the bottom line, it's a very simple data interchange format that consists of what are called key value pairs. You see there on the right, that's a single object. It's a single record, right? So you have your keys, values there on the left. They're essentially your kind of database headers in a traditional database view. And on the right, you have your values, right, that make up the key value pair. Now, those values can be strings, they can be integers, they can be arrays, they can be essentially other objects. You can have nested objects in there. But for the U.S. Turbine database, it's a relatively simple schema, and that's just a set of key value pairs. So again, if on the left there, if I were to paste in a URL, that's what I would get in my browser, right? But the point is, JSON is very easily parsed by machines. And as you can see, parsing 60,000 points happens very quickly. It's just a very efficient interchange format. What's so nice about these APIs, as I said before, you can customize them. I can add what are called URL parameters to that base API endpoint to really make these things incredibly customizable and flexible. So on the left there, I have some selected operators, things like equal, greater than, less than, in. I can combine those operators with my key values that I showed you before, essentially your column header values, to create customized returns. So in this case, on the right, I'm saying get all turbines within Anderson County, Tennessee that have a capacity of greater than or equal to 2 megawatts constructed on or after 2000, right? And I do that by just simply appending the operators there in the white to that root level API. So you can imagine that really opens the doors for people that have custom needs for the resource, right? And I can apply row and column filtering, I can order, I can apply limits. Really, the sky's the limit with that. As an example, if I went back to that simple geospatial application I had before, where I was rendering, there's the full database. Let's say I only cared about the turbines that were in Texas. I don't want all that extra data. I simply just change my URL in my code right there to say tstate equals to Texas. When I refresh that application, you'll see that I'm only getting turbines now in Texas. I don't care about anything else. Now I can easily apply those URL parameters to tools to make dynamic-driven applications. So in the top left there, I've appended those URL parameters to a slider that's essentially filtering dynamically by capacity. So it's very easy to build these dynamic-driven applications just by changing some simple URL requests. On the internal side, when we talk about updating the database, there's no question that there has to be security built in to these APIs. Now, for the Turbine database, we don't allow the public to write data to the database. It's essentially a read-only resource. But as I mentioned earlier, we have internal partners. We have multiple database authors that need security built in the database if they're going to push or update any of the data, right? So we do this through what's called JSON web tokens, okay? Essentially, what that means is if, for example, Joe from Berkeley Labs wanted to update the database here in USGS, I'd have to provide him a secret code, right? That code is stored on my end, and when he makes a request to push things, he has to send that request with that code in the header, and it essentially makes a handshake with the database that says, okay, this is Joe, he's allowed to write to this table. And because the web token has roles built in, I can limit his writing ability, for example, to a column, to a full table, to multiple tables. I really have a lot of granularity and security built into the API, right? So if I just wanted him to be able to update records after create date of 2018, for example, I could do that through the database roles. So it's a very important aspect that that shouldn't be overlooked in these things, that they can be incredibly secure with these web token technologies. It's very easy to push data to the API. In this case, I'm going to push 5 points out there in the Atlantic. So what I'll do is I'll connect to the API and then push 5 points in CSV format right there in the body. I'll send that to the API, and then I refresh my application. You'll see that they'll pop out there in the Atlantic, right? So again, very easy to push updates, changes to the API, and anyone who's connected to the API via application or software is always in sync. So it's a real-time connection to the database. I said earlier, workflows as far as internally, when we're passing around flat files, you can accidentally introduce error. If you're writing to the database via the API, we have built-in validation tools that say that help us with our QA/QCs. For example, I'm in this animation, I'm attempting to write a record that already exists, a unique ID that already exists, and it comes back and it says error, this already exists. Or if I want to write, if I'm attempting to write text into an integer field, for example, I'm going to get warnings explaining what's going on. So again, two very simple examples, but the point is that we have validation built into the database when we drive our workflows internally via an API as opposed to passing around flat files. One final piece that I use a lot with these APIs are these ideas of stored procedures or functions. So I can build in repeatable functions and call them from the API. So in this case, when I get an update from Joe and I push it to the API, I might want to, in this example, I'm looking for rogue turbines, right? So any turbine in this case with a long arc is potentially an error. We would expect to have these very small firework blasts, and you can see that there's potentially something going on with that guy. Well, anyway, every time we get an update, I can run this procedure through the API, generate all the things I need to create this visualization, and just extend the API through third-party application. So it's very flexible. It's not just for data delivery. It's data delivery, it's internal workflows, it's internal models, it's internal functions. A very robust internal tool for, again, building these resource endpoints. So those are just some highlights. We certainly have a much more deep dive of the API in our documentations page, which is available there. It gives you a lot more examples. It goes in depth about key value pairs, what it all means, error codes, all the things that are associated with this resource. But we invite you to try it, even if you're using it in Excel or R or any of your desktop applications, or even better if you're building custom applications with the database. That's what we really hope comes out of pushing this live.
Great, Chris. Thanks. That was really interesting. That was sort of a whirlwind tour of both what APIs are, what the functionality is for potential users, and also what potential functionality might exist for us internally as we think about the value of that. So that's just great. And I thank you for giving it so quickly. I realize that the audience is coming at this from lots of different levels of experience, and hopefully that gives everybody at least a flavor of it. As Chris mentioned, there is lots more documentation online for those that are more interested in it. And don't hesitate to reach out to us directly if you have questions about that, or to the full team at the U.S.Wind Turbine Database or USWTDB@lbl.gov. So we have a few questions that have come in since you've started talking, Chris. We have about 6 minutes to answer them. I think we can do it. If you have additional questions, if you haven't already asked them, please do so via the chat window, and we'll start going through the ones that we have here. So, Chris, the first question was, can you comment on the expected traffic load to this API server and how it will be handled to avoid issues?
Yeah, well, I can't comment yet, only because it's so we just put it out. But I mean, one of the nice things about this is that we have a group of virtual machines we can essentially scale as demand increases, right? So if we get too many hits on one of our machines, we'll essentially just keep scaling to additional virtual machines to kind of handle the load. So I don't have those metrics yet, but we're in good shape if we get hammered.
That's good to know. So kind of along the same lines, it doesn't sound like there are limits to the connection rate, the download, limits to numbers of downloads from individual users or hitting the API, some sort of rapid rate of downloading the entire database each time. Is that a concern, or will the scalability?
Well, I mean, I think as we kind of monitor the metrics, if it becomes a concern, then there's obviously we can add default pagination and only allow X amount of returns if by default, unless somebody really wants the whole thing, then they have to kind of force it. But right now we've kept it relatively open just to see the kind of loads we get if we just have by default that root level endpoint open to the entire database, right? But again, we can put controls in if it gets laggy or if it's just not performing.
Great. All right, so here's a question. This is a great question because it's very germane to the value of an API. The question is, does the database have any means of mapping or calculating wind turbines by congressional district? And I'll take a stab at this one, Chris. We don't have congressional district in the map. We do have XY coordinates. And so one could theoretically build a application that has those congressional districts in another mapping service. It pings the API and brings in the turbine database and therefore maps those turbines to the congressional districts. You would need an ability to map points to congressional district, but you could do that, and the API would be a good way to do that. Chris, do you have something to add there?
Absolutely. I mean, those are the type of things that are very easy to do, especially with an API, because you're just communicating those two, endpoints. I mean, we've leveraged the API when we were doing kind of early graphical visualizations, based on things like counties, how many turbines fell in these counties in these states, and so whatever kind of parcel we were using, and the API was great for that, and we were able to generate that on the fly, and just by changing some of those parameters, kind of get new metrics, get new visualizations, essentially with the change of a URL parameter. So the short answer is yes, that's certainly doable. Those types of parcel turbine relationship.
All right, so this is one for you for sure. Do you need, well, the first question is, do you need to be a coder or a tech person to incorporate the graphics shown? Or can an average person, maybe like me, meaning Ben Hohen, develop the ability to connect to an API? Specifically, this questioner is wondering about a WordPress site and how to incorporate this data to that kind of site. You probably know a little bit more about that, Chris. What do you think?
Well, yeah, the whole beauty of that, of the data return on the API is that it's compatible with so many platforms. I mean, anything, like I said, that can handle that simple HTTP response, you can leverage that package with, right? Much more extendable than if we just had a Excel file out there or something like that. So yeah, I mean, you certainly don't have to be a developer to leverage packages and just connect them with the API. I mean, you saw what we did with Excel. There's plenty of visualization packages, both map packages, open source packages, that dashboard packages that you can just connect to the API and via GUI kind of do what you're saying, like kind of whatever kind of metric you want or visualization you want. They make it relatively easy with some of these visualization packages.
Great, and this is more a question about database management. We're just about at the top of the hour, so I think we'll have time for this last question here. And the question is, when the turbine database is updated, can we tell the difference between a new turbine and the modification to metadata of an existing turbine? And that's
Ben, you could probably
question.
Answer that. I mean,
yeah,
we certainly have create date. Go ahead.
No, I was going to. I'll try here. So we have the at each release of the data, we have any updates to the data available on the website. All those changes are recorded, and so folks can get a sense as to those changes that are made. As well, turbines have a date in which they are installed, and so we do have that available as well. We have a date when they've been visually verified, so those are pieces of data that kind of give you clues. As well, we don't have it currently, but if, for example, a turbine has been updated, let's say, for instance, the turbine itself has changed and the turbine blades have been retrofitted, we don't currently have that piece of data in the data set, but we do hope to add it in the future. Anything more on this front, Chris?
I think that's, yeah. We've already had discussions about essentially adding that to the public-facing database, those modifications.
Yep, this little one little attribute or not
yep.
kind of changes. So that gets us through the presentation. Thank you very much, Chris, for joining us today, and thank you always for the excellent work that you contribute to this overall effort. Thanks, everybody, for joining us today. It was a pleasure, and we will be packaging up this recording and putting it online. So we'll see see you around. Please don't hesitate to contact us. Bye-bye.